In this video, we are going to discuss Gay-lussac's law. It is also known as pressure law. Let us look at the experiment, apparatus of the experiment. Now we have a round bottom flask, and we have pressure gauge to measure pressure, and we have thermometer here to measure temperature. Now we have a Bunsen burner, and it is used to heat up the water, okay, in the beaker. And look at the ice cube there. So we understand that in this experiment, we start our experiment with 0 degrees Celsius. Okay, first of all, let us look at the hypothesis of the experiment. The higher the temperature, the higher the gas pressure. Now, let us look at our manipulated variable. It is temperature, because we use Bunsen burner to heat up the water. And then look at the pressure here. The pressure is the responding variable that is measured by pressure gauge. And then our constant variable is the volume. Okay, you look at the round bottom flask. The volume of the round bottom flask is constant. It doesn't change. That's why it is the constant variable in this experiment. And also the mass of air, because the air in the round bottom flask is trapped there and it cannot escape from the round bottom flask. So the amount of air is constant. So the mass of air is a constant variable in this experiment. Since we start the experiment with 0 degrees Celsius, because we have ice cube there, and the pressure gauge is going to show certain amount of temperature, a certain amount of pressure. So we can plot a graph somewhere over there. At 0 degrees Celsius, this is 0 degrees Celsius. It shows the pressure gauge shows the value of the pressure there. And then when we heat it up, the pressure will increase. Okay, and then it increases for more when we heat up at high temperature, and then it will increase the pressure. Okay, when we look at this graph, we can draw a line, something like this. Okay, and when you look at this graph here, you cannot draw a conclusion yet, because you can see that the line does not intersect with the origin. So what you have to do now is you have to do the graph extrapolation. So draw a dotted line backward like this. Okay, and then you can draw the temperature axis backward, something like this. Okay, now in the actual experiment, the intersection there happens at negative 273 degrees Celsius. So what we do is we can shift this axis backwards, so it's going to be something like this. Okay, this is the p-axis. Now actually we have shifted it over here. So we can draw again this graph over here. Now it starts from origin. Now this is negative 273 degrees Celsius, and this temperature is known as 0 Kelvin. Okay, so here we have 0 Kelvin. So what is the temperature in unit Kelvin at 0 degrees Celsius? it should be 273 degrees Celsius. Okay, now when we have this graph, so we can make a relationship for this graph. So I'm going to draw it here. Okay, here's the graph that we have just now. This is the pressure and this is the temperature in Kelvin. Okay, and it starts from 0. So you can write P is directly proportional to temperature. And mathematically, you can write P equals KT, where K is a constant. So we have P over T is a constant. Let's say we have two situations. For situation 1, P1 over T1 equals K. And for situation 2, P2 over T2 equals K. Since K is the same, so we can write P1 over T1 equals P2 over T2. So this is the formula for pressure law. And you have to apply this formula in the question based on the information that you can get from the question.